Hi, everyone. So this should serve as a final naming review to help us get the hang of when to apply certain rules to naming compounds. We have 3 formulas down below, all of which are a little bit different, and we'll kind of highlight the main points that we need to think about when we're naming compounds. So the first formula here on the left is simply CO. It's a very simple compound, and the first thing we always need to consider when we're figuring out how to name a compound is what type of compound it is. We know that ionic compounds always start with a metal or the ammonium ion, which is going to show up as NH4. So if you see one of those, it's going to be an ionic compound. In this case, we have a compound that starts with carbon. Carbon is a nonmetal, as you know. It's in the upper right-hand corner of the periodic table. So this will be a molecular compound. So anytime you have a molecular compound, you know that you need to add prefixes. Now, the rule for the first compound, the first element in the compound, rather, is that you don't change the name. So this will be simply written as carbon. And if there is more than one, you will add a prefix. But since we only have one of that first element, we're simply going to write that as carbon. My apologies for the handwriting on the iPad. And then for the second element, we're always going to change the ending to IDE. So oxygen becomes oxide. And we always add a prefix, even if in this case there is only one of that element. So the prefix for one is mono, so this becomes carbon monoxide. So as long as you have a handle on the prefixes, as long as you remember to change that ending to IDE, you'll be able to name any molecular compound that comes your way. And you will be provided with that on your reference sheet in class. So now we have CuO. This is a compound that starts with copper. Copper, if you look on your periodic table, is a transition metal. So this is first an ionic compound, which means no prefixes. A lot of people, when they learn about molecular compounds for the first time, they tend to apply prefixes to all the compounds all the time. And you don't need to do that because the formula is based on the charges of the ions involved. So we will need to use a Roman numeral to figure out what the charge on that ion is. Anytime you have a transition metal or tin or lead, you're going to need to add a Roman numeral to indicate the charge. And figuring out that charge is very easy because you always know the charge on the anion, on the negative ion. If you're stuck on what the anion is, I recommend, as I'm doing right here, just drawing a line in between the two ions so you know which is which. In this case, we have an ion that is just oxygen, so just like with a molecular compound, we're going to change that ending to IDE, and that becomes the oxide ion. Now, if you look on your periodic table, oxide has 6 valence electrons. It gains 2 to form an ion, which gives it a charge of -2. That means that copper, since we only have one of them, must therefore have a charge of +2 so that the net charge equals 0. So this becomes copper 2 oxide, and we use that to fill in the Roman numeral. So again, the only tricky part here is making sure that you fill in the charge on that transition metal. Now, let's go over all the way to the right here. We have Cu2CO3. So we are not going to assume that copper has the same charge. We want to check, we want to figure it out just to make sure. So the first part of the name is simply copper, and we know we need a Roman numeral. We just don't know what it is yet. And we have to figure out what we have on the other side, and in this case, we have more than one element. Anytime we have more than one element in an anion, that is a polyatomic ion. Therefore, we need to look up its name on our reference sheet. By now, you've probably seen this one enough that you might recognize it as a carbonate ion, and you simply write that out. So we're 2/3 of the way there, and all we have to do is figure out the charge on copper. So carbonate has a charge of -2. You could look that up on your reference sheet, but again, you might be pretty familiar with that by now, that you can just write it down. And so here we have a total positive charge of +2. But in this case, since we have 2 ions, we just set up a quick little algebra problem where 2x equals 2. I think we can all handle that math. So that means that X equals positive 1, and the Roman numeral we're going to put in there is 1. And so our name is copper 1 carbonate. Hopefully this brief little review has helped you out, and feel free to spread the word and tell your friends. Thanks.